So for everyone that doesn't know me, then my name is Barry Cranford. I'm the founder, one of the organizers of the LJC. I actually founded it way back in 2007. So I'm not a developer myself. I'm in fact a recruiter, or I run a recruitment company called RecWorks. I originally started the group as a way to get our name out there as Java recruiters. And it was meant to be this 200 or 300 person group that every now and then I could say, hey guys, I'm a recruiter if anyone needs one. And it's got out of all control now. It's actually 7,000 people now, one of the biggest user groups in Europe. It's really done so much more than just this small group. But one of the best bits about the LJC, it's not necessarily the numbers, but the real sense of community that we've always managed to keep with all the great people in London and all the things that we do. So many people just come by, give up their time to help other people learn and develop their career. We've organized over 600 events in the LJC now. And that's all people giving up their time for free to help everyone learn. So yeah, it really is a great place to be for anyone joining us for the first time. Today, we wanted to do something a bit different than just a formal talk. Obviously, there's a lot of things going on in the wider world with the pandemic, and there's a lot of talks going on, people talking about Zoom fatigue and that kind of thing. And we wanted to create something that was as close as possible to everyone being in the same room and being able to chat and stuff. So we've done something a little bit lighter, something you can enjoy your lunch over and that kind of thing. And we want to know what you think of it afterwards. So like I say, as close to an unconference as we can. What we're going to do, in fact, the reason we've gone for lightning talks as well, I'm a huge fan of lightning talks. So I've spent my last 13 years or so watching developers' careers as a recruiter and being involved in the LJC. And I've seen the small things that people do that elevate their careers to new levels. And speaking and public speaking in particular is one of those things that people do and just brings people much closer to a career that they love. And so I've always been pushing it. I watched Trisha G give her first LJC talk, and loads of now keynote speakers give their first talk at an LJC event. And we've seen people give a lightning talk as a stepping stone to that. So I love lightning talks. So this seemed to be quite a good way of having this kind of lighter session over lunch, combined with lightning talks, and we'll get some breakout rooms as well. So anyway, without further ado, I'm going to hand over to our first speaker. So Tony, are you there? Tony Roberts?
Hi, yeah, I'm here. Hi.
Good. Okay.
Hi, everyone.
So Tony, I'll hand over to you then, and after 5 minutes, I'll be waving at you to say, that's your 2-minute warning. All right.
Okay, cool. So hi, everyone. I'm Tony. I'm the developer of a product called Jinx, which is a way of building Excel add-ins in Java. So I'm just going to show you a few slides. Can you see my screen? I'll assume that's a yes. I'm going to keep this pretty brief and jump into a demo as well. So kind of first of all, why would we want to write an Excel add-in in the first place? And really the reason is that most end users and business users are already using Excel anyway. So as developers, we may not see so much value in it, but like our end users definitely do see a lot of value in it. And what we should be aiming to do is to deliver tools to our users in a way that works for them, so they can get like the most value out of the code and the systems that we're building to help them, do whatever it is they do for the business. That's kind of our role. So give the tools to the users that they need in a way that suits them. And if we don't, then we know they're going to create these crazy spreadsheets and write VBA anyway. We can also think of using Excel as a front end for our Java code. So there's no need to write complex UIs. We can just use Java instead. And that also makes it a really nice kind of rapid development environment. And we'll see in the demo, we can iterate really fast as well. So when I talk to developers about Excel, like this is often the reaction that I get. People have bad experiences of VBA and VSTO and things like that. So don't worry, this isn't going to be something like that. We're going to be sticking with Java and the tools that we know. So yeah, so like I said, the solution really is to give users a toolkit of high-level functions to reduce spreadsheet complexity and get rid of VBA and stuff like that. And also, one of the problems you see in Excel is people copy and paste data from all over the place. So they end up pulling in data manually from different systems, whereas we can give them ways of connecting their spreadsheets to data sources to avoid all of that. So I'm just going to kind of skip all this now and go straight into a demo really quickly. When you download Jinx, which you can get from exceljava.com, what you get is these two files, which are the add-ins, so a 32-bit one and a 64-bit one. Those are what we load into Excel, and this config file, which is what tells the add-in kind of what to do. So here I've got, here I've got this config file, which is showing us what classes we're going to load, and there's a bunch of stuff in here for controlling settings and things, including the class path, like where we're actually going to pick up jars and stuff from. But I've got a quick project already set up with nothing in it, just to build as a jar. And if I add a Java class here, call it Excel functions, all I need to do is add this class to my list of classes here. So com ljc Excel functions. And now if I write some simple function in here, so something super simple like that. Now to get that into Excel, all I have to do is add this Excel function annotation, which is part of Jinx. Build this project. Let me move this across. And now in Excel, I've already got the Jinx add-in loaded. This ribbon here is an example where you can modify that as well. But now that's built, I should be able to do foo, yeah, my function's there. So X, Y, add them together. And when I said we can like rapidly iterate and stuff, I can now go and change this code here, rebuild this. So that's just building. Cool. And then without reloading Excel restarting, there's an auto reload feature in Jinx, which I've got turned on. But so now I can just go in, and now I've got a third arg, and that's running my new code. I can even set a breakpoint in here and just attach the debugger and step through that. So that really is kind of as simple as it needs to be to write an Excel function in Java. And because this is built as a jar, this is just sitting on the file system somewhere, or could be like a URL. You know, it's not VBA in the workbook. We're not having to touch VBA or anything like that. I just want to show you something else really quickly. I'm about 10 seconds running out of time. But here's some stuff I prepared earlier, just to show that as well as being able to write functions and macros and things, we can also add menus, and we can have access to the full Excel object model. So here, this Excel menu test thing I'll show you is getting the Excel application, getting a range, setting a value, and setting the color. So if, oh, this thing's in the way. Yeah, so now by loading that, I've now got this test menu here, which, let me just get this out of the way. When I run that, it runs my bit of Java code, sets the value on a cell, and sets the interior color. Okay, that's it. I'm out of time. So thanks very much for listening. And I think we've got a couple of minutes for questions if anyone has any.
Cool. Thanks, Tony. If anyone has any questions, can you use the virtual hand up function on Zoom? I believe it's done by pressing participants. Anyone have any questions there for Tony?
Silence.
Silence is golden. Okay, there we go. A lot of thank yous. Yes, very nice. A lot of positive comments there, but yeah, great. No questions. So thank you very much, Tony. Appreciate it. Oh, Fox has a question. We have a hand raised. Fox, yes.
Hello, guys.
Hi, Fox.
Does Excel for desktop support JavaScript? And in this case, isn't Visual Basic for Applications dead?
So that's a good question. So Excel, Microsoft announced Office.js a couple of years ago, which is JavaScript. It's still kind of pretty immature. Like if you try using it, you'll find that it's still very buggy and certainly orders of magnitude slower than even VBA. but using Java instead of VBA, you'll find is orders of magnitude again faster than VBA. So if you want like high performance stuff, then this is a way to do it. And also with the JavaScript stuff, that's a lot more complicated to set up. You know, it requires actually setting up kind of web servers and things, whereas this is just running Java locally. And also, if you're an organization which is already heavily invested in using Java, so you have lots of backend systems and analytics, then you know this is a way of reusing that. Barry's telling me I'm out of time, but thanks for the question.
Thanks, Tony. That's awesome. Thanks, guys. Everyone, please put your comments of appreciation in the chat, or add a little reaction in the reactions bar, just like that, so Tony can see the applause there. But yeah, thank you for that, Tony. Really appreciate that. So we are going to move on now to Anthony, who's going to talk about an amazing tool to manage different JVMs and versions of tools like Gradle and Maven in just 5 minutes. So good luck with that, Anthony.
I'll try my best. Let me share my screen over here. Can you guys see my screen? Okay. So, hi, my name is Anthony. This is my first white talk. If my sexy Brazilian accent gets in the way, or you have any questions, please shout out. I'll do my best to deflect all the questions. So straight to the point, what is ASDF VM? It is a runtime manager. So if you ever use something like JM or SDK manager, that's what ASDF does. But it's different in its own way. The first one is that it's extendable. So anyone can write a plugins for it. It's just like a Git repo with a bunch of bash scripts. And it can manage multiple runtime versions. So if you have project A that depends on JDK 11, project B that depends on JDK 14, and a specific version of Maven, you can do that. It runs on basically every OS. I'm using Linux. It works on Mac OS, and it works on Windows if you have Windows subsystem for Linux as well. And you can manage all of those, all of your languages from a single CLI application. Also, it allows you to manage both like global and per project configuration. So this is not my tool. The man to thank is Akash. There are more than 100 contributors working with ASDF. Very popular on GitHub. It's open source. It's very meta. It's awesome. So,
Anthony, just seeing people saying that they can see your desktop, not the slides.
Okay, let me see what I can do.
There we go, perfect.
Okay. So sorry for that. Okay, so the way that it works is basically you have plugins, and you add plugins, say for Java or Maven or Python, you name it. After installing those plugins, you can download your runtime tool, like adopt OpenJDK, for instance. You can install the version, and then you can set them both as local and global runtimes, okay? You can find more about the documentation on their website, but let's get our hands dirty a little bit. It's demo time. So can everybody see my shell? Okay, cool. So just to prepare for the demo, I already installed a few plugins here. So like Java, Maven, Docker are all managed by ASDF on my machine. If I list, you see that like Java is currently managed by the environment. And the version that I'm using globally, it's OpenJDK 14. So if I do Java version, that's Java 13. If I check what it is, it's on ASDF. The good thing about ASDF is that you can manage your environment per project. So this is like just a project that demonstrates how GraalVM competes with regular like Java JVMs in terms of code startup time. I will not go through the code with you, but it's a pretty standard Java project. It uses Java 11 and it uses Maven. If I run the project, you see that it's using app.openjdk 14. It takes a little bit of time to run. And then it also uses GraalVM, and it's quick to start. Okay, so I'm running out of time here. I just want to do something quite fast. I can set that this specific folder will use OpenJDK 11 instead of 14. Now, if I run my project again, it's using OpenJDK 14. Other than that, it created a tools version with project-specific configurations. I can push this to my repo, and whoever needs like the tools that I'm using can just do ASDF install, and it will install everything that they need in order to run this project. Okay, so that's it for me. It's quick and painless, like if anyone has any questions.
Thanks, Anthony. We did have a question that I don't know if you answered there or not from, was it Marie Collian? Can you manage local version of Java, for example, like you do with SDK man or env?
Yes.
You can. There you go. Any other questions for Anthony quickly? None coming through at the moment. Okay, no problem. All right, brilliant. Well, thank you very much, and Anthony, appreciate that. Number two. Again, everyone, feel free to add your claps, your reactions, your thanks to the chat message, and we will then hand over to Cesar, whose talk is going to be a little bit longer. I understand, maybe around the 10-minute mark. Did you say?
Yes, because it's like slightly theoretical, so it's hard to pack in 5 minutes.
Okay, fantastic. All right, no problem. Well, whenever you're ready, then.
All right, everyone can see my screen. Cool. Sorry. Oh, all right. So yeah, my name is Cesar. Today I will talk about fantastic types and where to find them. I'm a senior software engineer at Thousand Eyes. So very briefly, if you don't know about Thousand Eyes, we like to say that we are the Google map of the internet. So we run a lot of tests and we're able to monitor the health of the networks on the internet. And we have this product called Internet Insight, and we're able to detect outages in real time. We also have a product, that's the one I'm working on, that helps check connectivity from remote workers. So we've been really busy these days because everyone is working from home and everyone is using the internet. So it's been interesting. Anyway, that's not what I want to talk about. So I want to talk about fantastic types. In particular, I want to talk about ADT. So it's an acronym that you might have heard. It does not mean abstract data types. What it means, it's algebraic data types. So this is just an example in Kotlin. So in Kotlin, we could define a sealed class, like an interface, an expression, and we can say that an expression can be a constant, or it can be the sum of two expressions, or it could be not a number. So we can see here that we have a recursive definition, and we can define different things like that. I just want to show you a little bit of Haskell, because this is like functional talk, and Haskell is a very good functional language. So in the first line is basically just defining a linked list. And in Haskell, it's a bit confusing for Java people. They use a small lowercase letter for the type. So this is just defining a list of type A. And we say that a list of type A is either empty, so it's just the nil constructor, or it's built from a head, which is of type A, with your element, and a tail of type list of A. So again, here we have a recursive definition. We could also define a tree, a binary node, binary tree. So we can say a tree of type A is either empty, or it's a leaf that has an element of A, or it's a binary node that has two left and right elements of tree. So it's like recursive again. So it's called algebraic, and algebraic means it relates to an algebra. So, you know, what's an algebra? So in a kind of not very formal way, and this is something that you might be familiar with, to have an algebra, you need first you need a set of elements. So for instance, the natural numbers, 1, 2, 3, 4, etc. Then you need two binary operations. So you need like a plus and multiplication. You need to have a neutral element for plus, and in the case of natural numbers, it's 0. You need a neutral element for multiplication. In the natural numbers, it's 1. And then you need a set of laws, things like associativity, commutativity, distributivity. So I don't really have time to formally define those, but it's just to give you a feel for what an algebra is, and you're already familiar with it. Now, there's actually another algebra that you probably work with every day. It's the Boolean algebra. So the set of Booleans, so it's only two possible values. It's false and true. So 0 corresponds to false, 1 corresponds to true, plus corresponds to or, and multiplication corresponds to and. And once you do this mapping, all of the equations, all of the laws that you know from numbers, they apply to Boolean. So for instance, multiplying by 1 is always the same number, while if you take any Boolean and you end it with true, you get the same Boolean. If you take a number and you multiply by 0, you get 0, while in the Boolean algebra, if you end with false, you always get false. So the point of this talk is that actually types also form an algebra. So you can multiply and you can add types. And for me, the first time I came across that, I was very blown. I was like, well, this is incredible. How does it work? So let's try to figure out what it means. So if we define a new type and we say that the type animal is equal to the type cat plus the type dog, and it's maybe not necessarily very intuitive what it means, but if we think in terms of Boolean algebra, it becomes easier. We can say that an animal is a cat or a dog. And this is something that we're familiar with. It's just plain inheritance. Like a lot of languages have that. You can have like an interface and you can have multiple implementations. So an animal is a cat or a dog. So we're kind of familiar with that. Now, multiplication, well, we can say that themselves, the type cat and dog, we can say that cat equals string times int, and dog equals strings times int. And again, maybe this is not very intuitive, but if we switch the mindset into Boolean algebra, now we can say that a cat is a string and an int, and a dog is a string and an int. And that is something that we're familiar with. It's basically just creating field on objects. So if we look at, so this is Kotlin again. I really like Kotlin, if you haven't tell, if you couldn't guess. I can define a data class for a dog, and I can give it a name of type string and an age of type int. So in terms of type, a dog is a string and an int. So, and quite importantly as well, when you basically multiply two types, that corresponds to the tuple or to the pair type. So this is not something that exists natively in Java, but in languages like Scala and Kotlin, you have that natively. So multiplying two types, it means you create a new type that is a pair, and to create that tuple, you need to have the element of both types. If you're missing one, you cannot create the pair. So we kind of saw how it makes sense to kind of talk in terms of type with or and and, but maybe it's not exactly clear why it makes sense to talk in terms of plus and in terms of multiplication. And to understand that, we need to go back to the definitions of types. And actually, a type is a set of possible values for a variable. So if you define a Boolean variable in any language, your compiler knows that this variable can only have two elements, true or false. So any sort of type is a set of values that can be used by the compiler. So if we define some abstract type, so let's say the square type has 3 values, and the triangle type that has 2 values. And we want to know, okay, I want to create a new type, a square plus triangle. Well, from a set perspective, this just corresponds to the union. So I just create a new set and I pull all the values from all the other sets. And an interesting property to look at is something called the cardinality. And the cardinality just means how many elements you have in your type or in your set. And we can see that the new type has 5 elements, and that corresponds to 3 plus 2. So when we look at cardinality, we see that the plus makes sense. And if we think in terms of multiplication, so I said that the multiplication is the pairs. So basically we need to build every single pair between square and triangles. So when we do that, we see that we have 6 possible pairs, and that corresponds to 3 times 2. So this is kind of interesting to see why then we can talk about plus and addition and multiplication. So just to kind of summarize some interesting things, on the left we have cardinality or some equations, and on the right we have the types. So the number 0 corresponds to a type called void. So that's a very important type, even though probably you don't really use it most of the time. It's a type that doesn't have any value. So you can define variables of type void, but you can never create them. Now, the second one is a type that has only one element, and this is called the unit type, or sometimes it's called the double bracket. And that's a bit confusing. It confused me for a while. And this is basically, think of it as a type that has no information. It's like a static variable somewhere that you can always use. So when you say, for instance, that the list is empty, or it's a head and the tail, this empty that corresponds, this is one instance of the unit type. Now, number two corresponds to a type of 2 values, so it's the Boolean type. And now we can do things that are more interesting. So for instance, we can write an equation. We can say, if you give me any type t, what is the type 1 plus t? So if you understand that, it can be 1, so that is like no information, empty, plus, or something, and that is the optional type. So the optional type is Java is basically just 1 plus t. And again, it's the same for a list. We can say that the list is 1, that's just empty list, plus, or a head of type t and a tail of type list of t. And once the mapping that we talked about, all the algebra that we know, you can do the same with types. So for instance, equations like multiplying by 0 is with 0. Well, if you're trying to create a pair with void, because it's not possible, it's the same as void. So I don't know how much time I have, but this is basically now, I just want to show you that it's kind of, it can go a bit next level. When you have a functional language, often we say that functions are first-class citizens. So if you're using a type language, it means that if you create a variable that is a function, it needs to have a type. And often this type is represented with the arrow. So if A is a type and B is a type, A arrow B is the type of all the functions from A to B. And in terms of algebra, this corresponds to B to the power of A. So if you think in terms of cardinality, it means that if you want to know how many possible functions there are between A to B, you need to take the number of elements of B and you need to take it to the power of A. And what I find really, really interesting personally is that the equations that you would, maybe you learned at school about the exponential, then if you take them and you translate them into what it means for a function, you actually find things that are true and that actually make sense. So I don't have time to go through all of them, but I just want to show only the first one, for instance. So we know that it means that A to the power of B to the power of C is equal to A to the power of B times C. So if we translate that into a function, well, the first one is a function from C that returns a function from B to A. And the other one is, well, it's a pair. So B times C is a pair. So we take a pair of C and B and we return an element of A. And this is, if you know functional programming, this is something called currying. So if you might have seen that in JavaScript or other languages in functional programming. If you don't have, sometimes you cannot create functions of multiple variables, but what you can also do, you can curry your function to basically have always a function of one element that returns more function. And you know that this works mathematically based on something like that. Yeah, so I mean, I could talk more about this, but that's the end of the time. So yeah, thank you very much.
Great, thanks, Cesar. Does anyone have any questions? Yes, Fahad.
Hey, thanks very much for this talk. It's actually quite interesting. Where can we find more information about this, algebraic data types? And I've started to look on YouTube a bit about this, but I get lost every single time trying to actually delve more on the subject. So what would you recommend are good resources for learning this?
Yeah, so I will have to think about that, because I think the big problem in functional programming in general is that you either have very little information, or you find articles that are very theoretical, because all of that is based on very abstract mathematics, especially called category theory. So it's actually quite hard to find material that is at the beginner level. And that's what I've been doing in the last few years. For instance, I built a talk on monad. I tried to explain monad in terms of like very simple diagrams like that without going into much theory. So I think I will have to have a look online to see where you can find information that doesn't assume that you know a lot of mathematics. So maybe I'll get back to you on that.
Thank you.
Great, thanks, Cesar. And thanks to the others as well, to Anthony and to Tony for the first session then. I'm gonna hand over here to Zam then, who's gonna have the first lightning talk coming back. So Zam, you back now? Your door's answered. You all set up?
Yeah, Amazon is an important thing these days.
It certainly is. It certainly is. All right, I'll hand over to you then and start the timer and give you a 5-minute sign. 5 minutes.
Great. Thank you very much. Can everyone see my screen? Can anyone see my screen?
Yes.
Oh, perfect. Okay, great. That's good. So there we go. So my name's Zam, and I'm going to be talking about hash maps in Java. This is going to be a quick whistle-stop tour. I'm going to start off by giving you an overview of the classic implementation of the hash map, which is often called the bucketed hash map. And then I want to talk about some optimizations that Java makes on the original classical algorithm. Specifically, I'm going to be talking up to Java 8. Great. So here's the classic bucketed hash map algorithm. There's quite a lot on this slide over here, so I'm just going to whistle through it quickly. So in the bottom left, you can see what a node class definition looks like. It has a key, a value, and a next pointer to another node so that you can chain nodes together to form a linked list. You have in the center an array, which represents the backing store for a hash map. And if you look in the bottom right, you can see it in use. So if I want to insert John into the hash map with the number 32, I take the hash code of John, I modulo it by the size of the array, and that gives me the bucket position. And then if you notice, I take Erin, and I take that hash code, and I modulo it by the size of the array, and get the same bucket. So even though these two things have different hash codes, they end up in the same bucket. This is what's called a hash collision. Now, let's take a look at the worst case scenario. So obviously in the best case scenario, this is an O1 lookup. You know, you just get to the slot and there's either your item that you're looking for there, or there's nothing there if you're doing a lookup. Now, in the worst case scenario, you have, in this case, 8 different keys that have different hash codes, but actually end up in the same slot in the array, which means that you are effectively looking up in a linked list instead of a map, which can be ON. So what can Java do to improve this? Well, in Java 8, there's actually a nifty optimization where if you get to a list of size 8, it will actually convert your list into a tree, in this case a red-black tree, which is the implementation that Java chooses for this purpose. And all the keys in the tree are ordered by, well, if the key actually implements comparable and the map will look up via reflection whether the key does, it will use that comparator to determine the order in the tree. If you're curious, if there's no comparable interface, then it will actually use the hash code to order the items in the tree. And nicely, it will actually convert the tree back into a linked list if you drop below a threshold of 6 in a particular bucket. That's so that you don't have to pay the overhead and over the bookkeeping of keeping a red-black tree in a balanced fashion, which is quite nice. So let's take a look at another thing that Java does for us. So one of the high costs of the classical bucketed hash map algorithm is the cost of resizing. So if you need to increase the size of the backing array, you actually need to rehash every single key in the backing store. This is because 2 items that may have ended up in the same bucket as a result of being modulated by the size may not be in the same bucket once you've increased the size of the backing array. So rehashing every key can be quite expensive, particularly because the map doesn't know how that hash code function is implemented for your given key class. So one of the ways that Java mitigates this is that it will store the hashed value, the hash code from the key in the node object the first time it's inserted into the map. This means that the resizing operation is mostly just about memory copying rather than having to do any calculation involved in there. Well, too much calculation rather. You still need to do the modulo operation, but yeah, which is pretty cool. And that opens up another bit of optimization that Java actually does, which is to do with how expensive equals is. Now, equals can be somewhat, again, the map has no idea how the users implemented equals, but you could imagine if they had like an array being the key. To do an equals operation, you'd have to compare every slot in a particular array, like a byte array or something, which, you know, these things can add up, particularly if you have deep nested object trees. So Java has a pretty nifty optimization. So if we take this case over here, if I were to look up the key Ben, which is the one right at the end of that list over there, and it's 7 long, so it's not been treeified, I would have to do an equality comparison with every item in that list. But we can do slightly better in Java. This is roughly what the code looks like in Java to do the equals check against every node in the tree, in every node in the particular bucket. And as you can see, the top line actually looks at the cached hash code value that we discussed earlier. And we do a straight arithmetic equality check against the hash of the key that we're looking up. Now, we have already computed the hash of the key being looked up because we've arrived at the bucket that we're going to iterate through. So actually, this is a very, very efficient way of discarding negative results. So that lookup earlier with 7 items in the node is actually quite quick because you're just doing a numerical comparison against 7 different items potentially. And as a neat little second optimization, the equals implementation in HashMap will actually compare the reference equality of the item you're looking at versus the item in the node, which means that you only really have to do the equals in a few cases rather than in the majority of cases. So that's quite nice. And the last bit of optimization I want to talk about is what's called the is the power of 2 optimization. So if we take a look at the original classical implementation of how you work out which bucket a particular key should go in, if you take the hash code of John and you modulo by the size of the array, you get the bucket position. But modulo can actually be expensive in the relative term of micro-optimizations. It'd be quite expensive since a modulo almost always results in multiple operations, one of them being a divide, which most CPUs don't support on many of their ports. So you can actually do a nice optimization if the power of the array is specifically a power of 2, which is that you can do this, which is exactly the same as doing a modulo, and I've written a little bit explanation over here to show how that works. So if you take 8 minus 1 and you get 7, you get a mask of all 1s, which means that you effectively truncate any number, which is the same as the modulo operation. This has some side effects, and you'll see that in the Java source code. If you look up map, you can see that there's actually an additionally complex hash code function to make sure that you don't end up with all the bits at the bottom being overrepresented, which can lead to hash collisions. But you can read the source code to find out most of the information in the comments. That's just a whistle-stop tour. If anyone has any questions, I'd be more than happy to give a shot answering some of them. Thank you.
Any questions from anyone for Zam on that at all? Yes, Arthur? Arthur, did you have a question? I see your hands up. I don't know if you're on mute or.
Okay, can you hear me now?
I can, yes.
Yeah. Okay, great. I was just wondering if there are any further optimizations made in future versions of Java. I'm aware that this was just for Java 7, but Java 8. But is there any in Java 11 that you're aware of?
I haven't dug into the source code deeply. But I mostly use Java 8 on a day-to-day basis. I haven't quite upgraded just yet, so unfortunately I can't quite answer that question. But if you look at the if you look at the source code, not at the documentation at the top, but just below the starting point of the class, you'll see that there's actually a doc string for implementation notes, and I found that's quite helpful where they list the high-level overview of the optimizations they've made, and you'll see a bunch of information about the trade-offs they've made, which is quite interesting.
Okay, thank you.
Great, thank you very much for that then Zam. As Ilan said in the break there, I think we need to get some applause noises to play after the talks. I think that'd be a great shout. But please do show your appreciation. Add something to the chat. Add a little reaction to say thank you. And yeah, with that we will hand over to our final talk of Rafal, who's going to talk about recycling everything, or at least as much as possible, a gist of ongoing journey towards zero allocation in his project. So yeah, I'll hand over then to Rafal.
Hello everyone, great to have you here. All right, let me just show my screen. All right, my name is Rafal Foltynski. I'm a senior Java developer in LMAX and open source contributor. And today I'm going to talk about my project called Log4j to Elasticsearch, where I have exercised some techniques to optimize the memory allocation rate, which can cause issues to any running process. So what is Log4j Elasticsearch? It is a Log4j2 appender that is capable of pushing logs in batches to Elasticsearch clusters. So you probably know the AUX stack, or at least you heard about it. Basically, your application, once it writes its logs to disk, these logs are then picked up from files by Logstash and shipped to Elasticsearch, or they are picked up by beats and shipped to Elasticsearch, or they are picked up by beats, delivered to Elasticsearch, which then delivers it to Logstash, which then delivers it to Elasticsearch. But not a lot of people actually consider this approach, where you push your logs directly from the application to the Elasticsearch clusters, and there are reasons behind it. Because all of the overheads, all of the workload that was in a separate process, beats or Logstash, is suddenly moved into your application doing business, and you want your application to do business and not do some background work, filtering, processing, and shipping data anywhere, which was usually done outside of it. So what I've noticed during my profiling, during the profiling of this library, is that the first version of this library was allocating a lot of memory, and my baseline test was just to deliver 1 million logs at the rate of 10,000 per second, where each log had 200 bytes each. This 200 byte log is allocated once, so it's a single string. So the numbers that you can see on the right are representing the actual overhead of the stack. In case of one of the modules based on Jest, it's 190 megabytes per second. Let's have a look. Let's have a deep dive and see what's going on there. So almost 20 gigabytes allocated, 50 millions of byte rates, tons of linked tree maps, some linked hash multi-maps coming from Google classes, and tons of stuff coming from JSON. And I thought that cleaning up the Just API could be a good way to improve that. So I've introduced some object pooling and rewritten part of the API, which allowed me to get rid of almost 200 million objects and reduce the overall allocation to 3.2 gigabytes. This is still sending 1 million Elasticsearch documents, or rather 1 million logs converted to Elasticsearch documents. But this was still not enough. Still some stuff from Google, and some excessive amount of linked hash maps for some reason. So I've decided to write a completely new module. And this is the current master from the latest release. Delivery of 1 million logs needed 1.6 gigabytes and 23 million objects. And at this point, the actual I got to the last hardest bits to get rid of, which is some internal bits from Log4j and some internal data structures of Jackson, plus concurrent linked nodes from my library. So concurrent lists got replaced by JC tools. Instead of creating 2 million write contexts, I can cache a single JSON, single Jackson writer. Since the assumption is that this appender will be used behind the asynchronous logger. Every delivery from the disruptor to the appender will be done in a single thread. And these are the results from the very crazy and very development version of this plugin. I brought it down to roughly 600 megabytes and 7 million objects. And at this point, we have no Jackson-related objects, no Log4j related objects apart from the ones that are actually pulled. But the actual graph got a bit flat. So in order to collect some metrics on the GC, I would have to bump up the numbers. So that's what I did. I've bumped up the actual rate of logs to 50,000 per second, and this way I could deliver 10 million logs in roughly 3 minutes. And it actually proved that the solutions applied were actually working quite fine. You can see 80,000, some 80,000 buffers. These are the pre-allocated objects, and of course 10 million objects representing documents being sent to Elasticsearch. This branch is not yet released, but I will gradually release bits of it in chunks, because there are a lot of architectural changes and solutions that may require some contributions to third-party libraries. If you'd like to join me on this venture, feel free to do so. And that's all I have here.
Brilliant. Thanks very much, Rafal. Thank you. Has anyone got any questions then on any of that? Yes, Farhad.
Hey, thanks so much, Rafal. I remember us talking about this at the last LJC meetup last year, if you remember. So one thing I was just thinking about, and one of the reasons why I did consider looking into using this, but then the key thing was about the fact, of course, you have a network connection in the middle when you're actually doing it. And of course, network connections, as we know, are not the stablest things in the world. So what sort of kind of fail-safe guarantees do you have? So for example, if that dies, what happens to my logs during the application runtime?
So at the moment, you have at least four options. The first option is just to redirect your fail, all of your failed logs to a no-op appender, which will just drop them on the floor, and these logs will be lost forever. You can redirect them to a separate appender, for instance, file appender, and use logs-beats or your separate application to deliver these logs again. Or since the latest release from March, you can use a chronicle map failover policy. All of the failed batches will be stored in a file-backed map and delivered later.
All right. So in terms of ordering of this, so for example, if you were to push this onto disk, do we have at the moment in your branch any kind of tool that can replay these messages so that
at the moment, no.
Okay, fine. All right.
But feel free to implement one.
No, I can understand. Like I said,
one and contribute back.
Absolutely. Thank you. All right. Thanks very much.
Yes, Judd Gaddy, did you have a question there as well for Rafal? Judd, not sure if you're talking, but we can't hear you if you're
Sorry, yeah.
Yeah, there you go.
Yeah, just if you don't mind, just clarifying the overview of like the architecture of it. So you have lots of threads potentially writing to Log4j using the asynchronous logger, which will go into just multi-producer disruptor, and then there's one consumer, which is your code, which consumes those log events and then writes them sends them over a TCP socket, or what to?
At the moment, most of the components are using HTTP clients. There are 3 components based on bulk processor. This is the Elasticsearch client, Elasticsearch. A client provided by Elasticsearch, which uses TCP, but whichever way you use, every time you're going to make some sort of TCP connection, whether pure TCP or HTTP. So the architecture, once the consumer is provided by Log4j, it's a part of the async logger config. Once the log gets collected, it gets added to, at the moment in the current master, a linked list, which will get flushed once the batch size is reached, or once some interval has passed, for instance, 1 second, 10 seconds, whatever you wish, and then it gets passed over to to HTTP client, which will execute the batch asynchronously.
Okay, cool.
So the actual delivery, even if you use the synchronous loggers, should be quite quick. There is no overhead of actually processing the log downstream, writing it to a file. You just have to put it on the list, and that's done. It will get flushed in something like a second or whatever you configure.
Have you tried to use? I looked at this a bit, and it seems like you have to use the asynchronous logger to have garbage-free log events in Log4j 2.
Yeah.
The disruptor, yeah, you don't have a choice.
At the moment, that's the case. Although I am considering releasing, or I actually started to work on the pullable message factory. When you get the logger from the log manager, you can specify the factory that will produce your log events, and this factory theoretically can be pulled as well. But there are still some elements of Log4j that will allocate, so it will be very, very hard to get rid of, for instance, the thread local that is getting created on every log, and there's just no way to avoid that.
Did you ever consider, when you were doing this, just throwing away Log4j and just writing your own logger to write?
No, not really. Log4j is a very, very well adapted framework, similar to Logback. And what I would rather consider is writing the integration with Logback, and then writing integrations with more tools, maybe Splunk, maybe Datadog. Probably not. They have their own clients, but Splunk is interesting. I already have a development version that ships to Splunk, but it's just not released, and I would have to spend a lot of time bringing it back to life. Still, more integrations are planned. I think that I'll go for Logback to Elasticsearch first, and probably post some numbers, some comparison of actual Logstash beats and this plugin, and everyone will be able to decide which one is the safest approach and the most proper one.
Cool, thanks.
Brilliant. Well, thanks again for Rafal, and again, thanks for everyone. Please feel free to show your appreciation, gratitude on the chat app or with reactions. But yeah, thank you to everyone that took part in today, everyone that logged on, and I hope you got a lot out of it. We're going to chuck out an email that will have a feedback form. Essentially, we need to hear from you. If you want us to do this again, we're more than happy to put the time into getting all the organization side of it and all of that kind of stuff. If we've got people that A, are happy to speak, and B, want to hear those people speak, I really, really want to see this go a long way. I think we could weave in all sorts of different things. I said something on the LJC Slack group actually just before about this, but some kind of, in fact, it was Anthony's idea earlier about this, or we got there together about having a speaker workshop element to this, where I'm sure I could twist the arms of some experienced speakers to come on and offer some feedback on your talks and that kind of thing. Like, I think this could go a long way. Basically, it could be the beginning of a speaking academy or all sorts of other things. But of course, it depends on if you guys liked what you saw, you enjoyed it. Could I do anything better as well? I'm really interested to hear if I could have organized it better, if I could have helped either from the speaker side or the attendees, done anything to get it better. If you're talking to me, then be candid, don't be kind. I've heard it all, so tell me what I did wrong and that kind of thing. And yeah, like I say, I hope you enjoyed it. Please let us know on the forums, and we'll be back next week with some more events. Thanks very much.